Hello, students. This is STT 315, Introduction to Probability and Statistics for Business, and this is Recitation 1. And today we are going to go over some of the learning objectives and some examples that get at the learning objectives. So first, we'll want to identify experimental or observational units in a statistical study, differentiate between population and sample, differentiate between descriptive and inferential statistics, differentiate between a parameter and statistics, or a statistic, and classify variables as numerical and categorical. So I'd like to, before we go into some examples, just to briefly go over the definitions of the underlined items in the learning objectives, just to make sure that we're on the same page going forward. So here, an experimental unit or observational unit is an object upon which we collect data. And so an object, for example, could be a person, thing, transaction, or event. Population is a set of units, usually people, objects, transactions, or events that we are interested in studying. And here for population, the entire set of data for which information is desired. And so a tip for this is to look for like keywords that are like all or entire or everyone, and we'll see some examples later on in this video. And then a sample is a subset of the units of a population. So it's not the entire it's not the entire population, it's a subset. So that is a sample. And then we have descriptive statistics, which utilizes numerical and graphical methods to explore data. For example, to look for patterns in a data set, summarize the information revealed in a data set, and to present the information in a convenient form. And descriptive statistics summarizes the data set collected, where inferential statistics utilizes sample data to make estimates, decisions, predictions, or other generalizations about a larger set of data. So here, inferences make statements about populations, the data for which information is desired. So that's a way to kind of differentiate between the two, where descriptive statistics summarize and inferential statistics make a statement about the population. Parameter, so a numerical descriptive measure of a population. Because it's based on the observations in a population, its value is almost always unknown. And a sample statistic is a numerical descriptive measure of a sample. It is calculated from the observations in the sample. And in most situations, the population parameters will be unknown while the sample statistics will always be known. And so a way that I kind of remember and differentiate between parameter and statistic is, so a parameter deals with a measure of the population. So I think P and P, where a sample statistic is a numerical descriptive measure of a sample. So I remember S and S. So that's just a little tip for differentiating a parameter and a statistic. And then last but not least, we have quantitative data. So that's measurements that are recorded on a naturally occurring numerical scale. And then we have qualitative data, measurements that cannot be measured on a natural numerical scale. They can only be classified into one of a group of categories. So another way to think about qualitative data is that they are non-numerical. So if the data is numerical, it's quantitative. If it's not numerical and categorical, then it's qualitative data. Oops, sorry, that was... Okay, so task 1 In a football league, the worst performing gets get teams get the opportunity to select the best quarterbacks coming out of college during the draft. A journal collected data for all 328 quarterbacks drafted in the past 40 years as part of a study. Several variables were measured for each quarterback, including weight, college attended, and production score. Higher scores indicate more productive quarterbacks. The researchers discovered that weight is only weakly related to performance. They concluded that heavier quarterbacks do not appear to perform any better. What is the experimental unit for this study? So here the answer, spoiler alert, is quarterback, but let's talk about why. So again, an experimental unit is an object upon which we collect data. And so if we look here, there's several variables that were measured, several variables that were measured for each quarterback. And then it includes weight, college attendance, and production score. So for each quarterback, we get this information. So the quarterback is the object for which we are collecting data. So that's why our experimental unit is a quarterback. In other words, we're not gathering data for different draft positions or the whole football team or a researcher, or we're not gathering a bunch of data on colleges. We're gathering the data on the quarterback. So that's why on each quarterback. So that's why that's an experimental unit. So identify respectively the type, so whether quantitative or qualitative, of each variable measured. So here were the variables. We have weight, college attended, and production score. So, and then note that the production score is a value calculated from a player's statistics to measure their performance. So let's first talk about weight. So weight is naturally occurring on a numerical scale. So in other words, we have weight in numbers, so that would be quantitative. College attended, however, would be qualitative because that's more categorical. We have different colleges like Michigan State University or University of Michigan or a University of Washington. So the college is qualitative. There's it's not on a naturally numerical scale. And then production score, so that's a score and that's a value that's calculated from the player's statistics. So that's a numerical variable. So that's why the production score is quantitative. So that's why A is the correct answer, where we have weight is quantitative, college attendance is qualitative, and then production score is quantitative. Is the study an application of descriptive or inferential statistics? Explain. So just to refresh our memory, let's look at the definitions for descriptive and inferential statistics again. So descriptive statistics summarize the data set collected. In inferential statistics, so we have to keep in mind that inferences make statements about populations. Okay, so again, we're tasked with what is if the study is an application of descriptive or inferential statistics. So the correct answer is B, where the study is an application of inferential statistics because it used the sample of 328 quarterbacks to draw a conclusion about drafting quarterbacks in general. So this goes back to making statements about the population. So we were able to draw conclusions about drafting quarterbacks in general because it used the sample of 328 quarterbacks. Okay, so here's a new task. So all highway bridges in the United States are inspected periodically for structural deficiency by the Federal Highway Administration. Data from the Federal Highway Administration inspections are compiled into the National Bridge Inventory. Several of the nearly 100 variables maintained by the National Bridge Inventory are listed below. Classify each variable as quantitative or qualitative. Okay, so quantitative deals with numbers, and qualitative deals with more categories, things that are not numbers. So length of the maximum span in feet, that's going to be quantitative because the length, for example, 10 feet versus, well, it wouldn't really be 10 feet, but let's say, 500 feet or something. That's quantitative. It deals with numbers. Number of vehicle lanes, that's also quantitative, whether it's one vehicle lane, 2, 4, 5. That's quantitative. 3, a toll bridge. So yes or no, whether there's a toll bridge or not. So that's not numerical, so that's going to be qualitative. Average daily traffic. So that's going to be quantitative because that is numerical. Condition of deck. So whether we have 3 categories here, whether it's good, fair, or poor. So that's going to be qualitative. Bypass or detour length. So that's going to be in miles. So that's also quantitative. And then route type. So interstate, US, state, country, or city. So here are different categories. So that's going to be qualitative. For each of the following, determine whether the quantity described is a parameter or a statistic. So just to refresh our memory, a parameter is the numerical descriptive measure of a population, and a sample statistic is a numerical descriptive measure of a sample. So remember, parameter, population, statistic, sample. And to keep in mind when we're talking about population, we want to look for words that like all or entire or everyone, where a sample is a subset of a population. Okay, so here so we have the proportion of all Lansing Whole Foods employees who regularly ride the bus to work. So that would be a parameter because we're looking, here's our keyword, all of the Lansing Whole Foods employees who regularly ride the bus. So here's our keyword, all. B, so the average number of barges docked at the Los Angeles Industrial Shipping Port on a random selection of 20 days. So here, a random selection of 20 days, that's not, and it's an average number of barges. So here, this is going to give us a statistic because that deals with a sample. And I don't see any of our keywords like all or entire or things that would indicate a population. Okay, so C, the average number of pets owned for the 90 families surveyed this past weekend at the Huron Valley Humane Society. So that also is pertaining, or that's also a statistic. We're dealing with like a sample for 90 families that are surveyed. So in this past weekend, so that jumps out as a subset of a population, in other words, a sample. So here the C would be a statistic. And then D, the proportion of all 2015 Cass Tech High School graduates who took AP statistics at Cass Tech. So here we have the proportion of all of these graduates. And so that's going to be a parameter because we're dealing with the population. And here's our keyword, all. So to summarize, we would have parameter, statistic, statistic, parameter. Okay, Is the following study descriptive or inferential? In a statistical magazine, average professional athlete salaries in 3 sports were compiled and compared for the years 1993 and 2003. So here we have our 3 different sports and sports A through C. And in 1993, we have the following average salaries for each of the sports. And then for 2003, we have the average salary for each of the sports. So here, this, so the question is if it's the following study is descriptive or inferential. So here it would be descriptive because the statistics are a summary of the average salaries of the professional athletes in the 3 sports. So that would be out of the 4 options, it would be D. Task 5A. Recent college graduates with an engineering degree continue to earn high salaries. An online search revealed that the average annual salary for an entry-level position in engineering is $80,000. What is the relevant population? So here, the population is all recent college graduates with an engineering degree, which is written right here. And then the second question is, do you think the average salary of $80,000 is computed from the population? Or sorry, do you think the average salary of $80,000 is computed from the population? And so the answer to this would be no, because the average salary is a sample statistic computed from a sample and not the population. Task 5B. The accounting professor wants to know the average GPA of the students enrolled in her class. She looks up information on Blackboard about the students enrolled in her class and computes the average GPA as 3.9. What is the relevant population? So here the population is all students enrolled in the accounting class. Part B, do you think the average GPA of 3.29 is computed from the population? So the value 3.29 is computed by drawing results from the actual population. So the answer would be yes. And then is the GPA of 3.29 a parameter or a statistic? Here it would be a population parameter. And here are the solutions, which I just went over. All right, task 6A. Which of the following variables are categorical and which are numerical? If the variable is numerical, then specify whether the variable is discrete or continuous. So colors of cars in a mall parking lot, that would be categorical because we would have, for example, black, silver, white, those are colors, they're not really numerical. Part B, time it takes each student to complete a final exam. This would be numerical and it would also be continuous because time is on a continuous scale. So it could take someone 50 minutes, it could take someone 15 minutes, it could take someone 45 minutes and 25 seconds. So that's why this would be considered numerical and continuous. C, the number of patrons who frequent a restaurant. So this would also be numerical. However, it would be discrete because we wouldn't have fractions. So we would have, whole number of people. We wouldn't say 2.5 people entered a restaurant. So this would be numerical and discrete. Task 6B, which is our last task. In each of the following scenarios, define the type of measurement scale. So an investor collects data on the weekly closing price of gold throughout the year. This would be a ratio. An analyst assigns a sample of bond issues to one of the following credit ratings given in descending order of credit quality. So increasing probability of default. So we have a AAA, and then AA, and then triple B, and then a double B, C, C, and D. So here, these have order, so it would be considered ordinal. The dean of the business school at a local university categorizes students by major. So here we have accounting, finance, marketing, etc. to help in determining class offerings in the future. Here, this would be a nominal measurement scale.